Hi students, welcome to HSC Earth and Environmental Science and Module 7 Climate Science. This is video 25. We're going to have a little bit of a talk about some geoengineering strategies. In this video, we're going to see if we can evaluate scientific evidence for the usefulness of a range of mitigation and adaptation strategies, and this time we're going to be focusing on geoengineering. So of course, the first question is, what is geoengineering? And geoengineering is the large-scale interventions that are designed to counteract global warming. You can see that there are two main approaches. The first is called carbon dioxide removal. So this is an attempt to try and get rid of some of the carbon dioxide, back to that idea of carbon sequestration that we've talked about previously. The second is solar radiation management. So I'm going to use these little acronyms, CDR for carbon dioxide removal and SRM for solar radiation management. So our problem is we've either got too much solar radiation coming in and not enough escaping, or we've got too much of a blanket that's holding that solar radiation in the first place. So what sort of strategies can we use in order to try and counter some of these building carbon dioxide levels in our atmosphere? So when we're talking about carbon dioxide removal, what we're talking about is targeting the cause of global warming by removing greenhouse gases from the atmosphere. So this is trying to get rid of CO2 and other greenhouse gases out of the atmosphere. SRM, on the other hand, the solar radiation management, is designed to try and offset the greenhouse gas impact by reflecting some of the sunlight away from the Earth. So actually trying to push some of the light and heat, solar radiation, back into space before it becomes trapped in the Earth's atmosphere. You can see from the diagram that I've got here a couple of different types of methods, and we'll talk about some of these in a little bit of detail in this video. So the first one we want to talk about is CDR, or carbon dioxide removal, and you can see that there's a few areas where this is already being done. Probably one of the big ones is the bioenergy with carbon capture and storage. So trying to actually take some of the material. Our biggest problem, remember, is that a lot of that carbon dioxide that has been converted into solid form, such as we find with coal, for example, has been buried in the ground and has been there for a very, very long time. And when we've dug that up and burnt it, that carbon dioxide is returned back into the atmosphere. It's very difficult for us to pull it back out again, certainly not for any sort of length of time. So one of the things with bioenergy, carbon capture and storage is we're trying to take some of that biomass that often just cycles carbon dioxide around and permanently burying it in the ground or putting it under the ground so that we can hold that in store and not release that carbon dioxide back into the atmosphere, certainly not as quickly. Some of the other strategies that you can see here include ocean fertilization or enhanced weathering and ocean alkalinization. We've talked about ocean acidification, so alkalinization is the reverse of that. So trying to raise the pH of the oceans rather than watching them fall as a result of acidification. Afforestation and restoration is another strategy which involves planting forests and restoring ecosystems. Direct air capture of carbon dioxide and storing of that carbon dioxide is another way we can try and look at removing that excess carbon dioxide from our atmosphere, and soil capture and sequestration. And another area where we can perhaps burn biomass, turn it into charcoal, and put some of that solid carbon back into the soil, which obviously is also going to help enrich the soil. Soils that are high in organic nutrients often make them much better quality soils anyway. All of these strategies, and I guess one of the things that I should say about geoengineering is these are still strategies we are working on at the moment. We don't know a lot of the long-term impacts of these sorts of strategies. We're still getting information about them. So the science is certainly not settled on these as yet. They are strategies that we're trying to use. If the levels of carbon dioxide are high, what are some of the strategies that we can do to try and lower them? And one of those is, of course, to see if we can take some of the carbon out of carbon dioxide and basically store it somewhere. So we're looking for a sink, or at least we're looking for a couple of different potential sinks where we can take this carbon dioxide out of the atmosphere and pop it somewhere else. Now, SRM is solar radiation modification, and again, there's a couple of areas where we've been looking at ways where we might be able to do something to reduce the amount of solar radiation that's reaching the Earth's surface, or maybe increase the amount that's actually going back into space. So this is a different kind of problem, and it does include some stratospheric aerosol injections. We did talk about particulate matter when we were talking about volcanic eruptions and the effects that they might be having in the stratosphere, where some of those particles are actually reflecting some of the solar radiation going back into space. And so this is what we want. If not as much solar radiation reaches the Earth's surface, then less of it hopefully will then be around to continue that idea of increased temperatures. Cirrus thinning is another strategy that comes under the SRM label, and also surface albedo. And this has been one of the interesting things when we start to look at the problems with our cryosphere, with the reduction in the amount of snow and ice that we have on the planet. And we know that those white surfaces are fantastic for reflecting solar radiation. As they decrease in area, so we decrease the that albedo effect. So how are there ways where we can create surfaces that will do the same sorts of things? We'll be able to create that whole albedo effect and return some of that excess solar radiation back into space. Marine cloud brightening is another strategy that has also been used. Once again, these are still fairly new, and we certainly I wouldn't say that the science has settled on a lot of these areas yet, but they are strategies that we are employing to see if we can think about, in this case, solar radiation, which is reaching the Earth. And what we're trying to do is we're trying to put little barriers in here to either stop some of that radiation from reaching the Earth's surface, or to try and push more of it once it's hit the Earth's surface back into space. So two different strategies, both coming under this umbrella of geoengineering strategies that are designed to try and mitigate. Remember, we're trying to either reduce the impact of our solar radiation, or we're actually trying to reverse that, to look at what is actually the cause of this increase in carbon dioxide buildup and whether there's anything we can do about that. So maybe we can't necessarily stop some of these releases of carbon dioxide, but maybe there's ways of being able to pull some of that excess carbon dioxide back out of the atmosphere, and or maybe there's ways we can do something about the amount of solar radiation that's coming in. So two different types of strategies applied to our understanding of atmospheric change and the idea that the atmosphere is holding excess heat, which is increasing the temperatures around the planet. So we'll have a look at both of these strategies in a little bit more detail during class. Thanks for watching.